So my name is Dánial Fey, and I'm a product manager for Cloud Application Manager. So that's part of the Cloud Band organization here in Nokia, where we are delivering portfolio of products in the cloud domain. First of all, we are delivering an OpenStack distribution, which is also featuring our root cause analysis system, which is another OpenStack project, Vitrage. Maybe you heard about it. And then it includes a layered set of management products as well. And one of those is the product what I'm managing. And I'm going to give this presentation together with Gabor Marton, our chief architect. I'm working in this building, and I see many faces as well coming from our company. And yes, that shows that we are pretty much focused on this technology. So what I'm going to speak about today, I'm going to introduce our intellectual journey, how we have been designing a template system that is used to manage applications in OpenStack environment. This is something which we have been doing roughly a year ago. It took a couple of months to complete. And that was very interesting design work, what he had to complete. We are through a couple of similar exercises, but we have been doing over the past couple of years. And that's a new incarnation which is trying to absorb the latest information, latest impacts that we're receiving in this industry. So yeah, telco goes to cloud. That's very important that we see that all the different parts of the telco networks to be going in a cloudified world, in a cloudified way. Right? This includes, of course, the main networks, core networks that are running the telco core network, but it also goes to the edge, right? So it goes to the edge cloud, to radio as well. That means that there are really multidisciplinary work that has to be performed, and all these ingredients, components that are making up a telco network to go really cloudified, right? So what it brings us, the cloud, right? The cloud is all about automation. The automation is that finally giving efficiency in performing the different actions to avoid mistakes, to be less error prone, to basically get away that the old manner how telco products were managed, that we are doing MOPS, basically method of procedures manually to set up and operate the hundreds of components of a telco network, or maybe even much higher in size. So for us, it's extremely important to understand what are the key factors in driving this whole transition, and the agility of managing the applications was a key factor on that. So this presentation will look at how we are able to do such automation steps to really bring the value of the clouds to our customers and to our industry. So automation. Yeah, what type of automation we want? So you can do one time, right? So you write an automated installation for some application or automated upgrade, but we need to make it repeatable. So we need to make it really reusable, that the investment, what it goes to any kind of automation, can be reused in many similar products what we have. So basically, I would define that the automation is composed by an automation engine and the template system that drives this automation engine. Just having an automation engine obviously doesn't take you too far. You also need to have a flexible template system that is able to parameterize the automation engine so it provides you repeatable automation, right? So we are working with an application template system. So a template system that describes how an application looks like from external point of view, what are the connectivity details, how it looks internally, what you need to do with this application to perform lifecycle operations, what are the parameters of those. So these will be addressed later on the upcoming parts of the presentation. So as said in the beginning, we were designing a template system roughly a year ago. Yeah, that's already now in production. So we have product working on the market based on the results what I'm explaining. And we are through the exercise. So this is a little bit looking backwards at how we went through the different steps. What were the actual key factors, key driving principles that we have been taking in account when we were doing the design work. Right, that's a joint work between more business and more technical people. We need to serve a business purpose, but we need to be well embedded into the current technology trends. The main objective is to deliver full automation. What it means, in my perspective, means that most of the telco application operability or operations can be done first in a single-click way, right? So you just triggers an operation, give some parameters, but you don't need to take care about the details what are happening there. But additionally, it may also need to be triggered in an automated way. So not just the actual execution, but triggering also needs to be automated. So we need a system, a template system that captures all these aspects in one. Now, I mean, I don't think that there's a one-size-fits-for-all type of approach. There's no one single template that needs to, or that can cover actually so many different tasks that we have to complete. So we see that there are multiple different ingredients, what you need to select, and you need to put together that finally will be working smoothly as one integrated way to handle all these tasks. Right? From our perspective, that was a lot of work to find these ingredients that were nicely fitting together. Then it needs to be generic. So generic means that we are not specializing in one or other application domain. You don't need to narrow your view to a certain domain. Actually, you try to build on such existing technologies that are already proven on the field, which are more or less community-based. So actually the community was working a lot on defining the capabilities, adding many different capabilities from different angles. Now we try to reuse those as much as possible. So this needs to be, of course, expressive and enough flexible to handle the different use cases. Openness is also very important. So we are, again, through a number of iterations in this exercise, and we have also been trying to work with some proprietary template system, which, I mean, we have the capability to steer in one or other direction in a free way, but at the same time, of course, we are narrowing down the potential of the template, the potential of use, right? So it's too much working in a silo. So we understood that we definitely need to build as much as possible on community assets, but at the same time, we need to take in account standardization. So the whole telco industry is very much about standardization. We have a lot of components creating the network that are working and interoperable over standardized interfaces. So our customers have the possibility to make the choice that how they are composing their network from the assets of the different vendors. So the application management domain is not an exception. There are several initiatives to do standardization on that, and we are taking those in account. Now let's speak about a couple of use cases, right? So I'm going to go through this way of thinking, how we ended up in a certain set of technologies, what we have selected. And later on, Gabor will actually show a couple of use cases. I mean, looking really at the template file, so that would be a bit more deeper dive technical session, right? First, I mean, what you need to manage the resources. It's evident that you need to set up the resources of these applications. We have Heat, right, in OpenStack that's developed together with the OpenStack. That's a no-brainer that has to be used, so that has a good template format which is flexible in a number of different ways, and it's evolving along the OpenStack. So if you want to select some templates, how to create the resources of your application, that's just given, right? And of course, in order to really set up these applications, you need somebody who understands really Heat. So in what I'm showing that we have Joe, our local hero, who really understands OpenStack. So he's the guy who is going there, creating the stacks, doing the parameterization, checking that everything is right. So this is a part of setting these applications up. Now, yeah, a little bit different thing. What you see here that we have the box there, which is called VNF, right? That's a new terminology that has been introduced as a part of this standardization work. It's called virtual network function. Don't think about any complex thing here. So this is, in practice, one telco application that has one unified lifecycle management and defines an elementary functionality. What you can, of course, further compose, and many of those can make up to some useful feature what one would use with a mobile phone. So our template system is actually geared to manage VNFs as telco applications, and I'm going to use this terminology quite a few times in the next slide. So now we are through that. The resources of this VNF are set up, but we are not yet done. We need to do a few other things, right? We need to do commissioning or initial configuration of this VNF. What you get, basically, a set of images. Maybe there are quite a few different images. These are booting up, and you need to make a consistent application out of those, right? You are not required, and actually it's not a wise tactics to hard code all the lot of parameters what you have with the applications. Instead, you would like to make all these parameters configurable on the fly during the instantiation. So your images are booting up, then you make some configuration actions that are forming from a set of distributed virtual machines one consistent application. Yeah, for that, of course, you need to perform a lot of different tasks over a lot of different interfaces. Again, we have a lot of applications here in the telco network. Some are new, using some modern interfaces. Some are just around the transformation paths, and these may use some more legacy interfaces. You need to select one engine where you are able to capture all of these tasks, or let's say most or 90% of these tasks, in a flexible way, in a way that you are not narrowing the scope of the work down to something really minimal. So we have selected Ansible playbooks to do such work. Basically because Ansible is, first of all, very nicely integratable in the template system, doesn't want to live on its own, a separate life. And second, it's interface agnostic, right? So with this module system, you can add support for whatever interfaces the application has. The extension possibilities are quite endless. Okay, are we done? No, not yet. So we have an application which is having all those resources ready, and it's initially configured, but in the telco network, we have some additional complexity as well to take care. So we have here the EMS, right? I'm sorry, the boxes are not fully visible, right? So there were some additional graphics to show structuring, but the projector is not exactly bringing those out. So the EMS is the element management system, and basically all the VNFs, all the telco applications are connected to some element management system that controls the detailed configuration management of these network elements. This can take up tens of thousands of parameters to configure in a radio network right around us. That's really complex stuff. So you don't want to do that during the initial configuration with some Ansible scripts. There are defined interfaces for this mass configuration. Then you want to monitor these. You want to have fault management, performance management, and a few other tasks as well. Now, you need to tell the EMS that you have a new VNF to take care. You need to integrate these two systems together. For some traditional EMS, it was found that Ansible is also a very good tool to make this interaction between these two elements. So we understood that let's reuse the same concept for this purpose as well, but that's a different type of workflow. So we need to still do something a little bit differently. It's not just focusing on the VNF itself, it's also taking account external system components to manage. By the way, in the telco standardization, these interfaces now are receiving something more standard, so this interaction between VNFs and EMSs become a little bit more clear, more defined, and that will not necessarily require Ansible all the time. Instead, we need to implement dedicated specific interfaces in the future. Now let's summarize what we have learning so far, right? So we need to have resource configuration, we need to have application configuration, we need to do some interaction with surrounding peering components, so this VNF is fully integrated in the telco network. That's a lot of work. It requires different disciplines, different personas to perform different knowledge. You don't want to do that by really hiring these persons. You want to automate the full process, right? You need to make it repeatable, you need to make it scalable. So these thoughts form the cornerstone of our template systems. And let's start to build from bottom up what we have. Yeah, first one, we selected Ansible playbooks and then Heat. Okay, no more explanation on that. I think is pretty clear. Then what we have added on top of that is OpenStack Mistral. Mistral is a workflow engine which is rooted in OpenStack. That's also very, very important for Nokia, right? So we are giving the project technical lead, actually. And we have found that Mistral, it's really a brilliant solution to make simplified workflows. There are some more traditional and maybe more complex workflow management system out there, but actually this complexity also kills the ease of use. Therefore, we wanted something which is more convenient, and Mistral was really fitting for the purpose. Today, my colleague from our R&D is going to give a presentation about Mistral, so I'm just calling the attention. I think it's going to be interesting about performance, a lot of measurements, and so. Good. So now that's where we are. Mistral to drive workflows that will be connected some actions over Ansible and as well as Heat. Let's move forward. Now we have a couple of more standard use cases in the operations of network elements. So scaling, right? We really assume that our customer base is going up, right? We have more customers in a sunny case, and you need to extend the capacity of the network. That involves scaling, right? Which is a natural thing in clouds. You need to take advantage of that anyhow. So that's, again, a complex action where you need to perform resource management changes as well as commissioning, so these new resources are fully introduced in the cloud. And you also need to automate. So that's just another use case, like an initial deployment, very similar. Then we move forward, we may see a bit more complex situation. So what happens if something goes wrong? We are in a rainy day, some resources are lost, some resources are not performing well. You need to do some healing actions. Then, I mean, it's not really an option to do it manually, because if you really want to get to the office, a couple of persons, even, I mean, on a fast track, but they need to get together, they need to perform certain actions local, that's not so good. You want to prepare for these cases, and you want to implement some automated workflows, operations that are immediately possible to be triggered, maybe in a fully automated way. So you need to have dedicated healing workflows for the different failure scenarios prepared. And as we move forward, we can see upgrades. So upgrades for us seem to be the most complex operations to support. It's not always needed, but in case we need to do in-service online upgrades, right, in such a way that the VNFs are continuously serving the customers while these are upgraded, let's say changing the images on the fly, that starts to be a complex operation. You need to really work out something which is really VNF specific. It takes in account the architecture of a specific VNF. And for that, you need another level, another scale of automation to make that work. So with all these said, we are extending our template system. So we say that we have Mistral, and we need to explain a bit how Mistral is used. There are a couple of standard cases like instantiation or scaling. For that, we can pre-program a couple of workflows which are there. It's easy to use. You don't need to add too many things, right? You just add your Ansible and Hotfire and you're good to go. In case of more complex things like an upgrade, we give the possibilities of the users to program their workflows fully within that environment what we provide in this automation engine. And that will be delivered as a part of the template package, right? So you package together all the different templates, what you have, and you include all your custom workflows, what you would like to do. But of course, you can extend for your own use cases. There's no need to just think about these couple of things. You can think about backup, restore, and so forth, different monitoring tasks, checking whether everything is okay, and if not, re-establishing certain configuration on your VNF, right? So we are completing basically a next level of our pillars, and let's move forward. What we still need to have. Now I'm introducing to you a bigger picture of this whole virtualized telco network. so far we said that we need certain automation that connects to the EMS and the VNF from somewhere. Now let's give it a name. It's called the VNF Manager. So the component that is responsible to lifecycle management and monitoring of the VNFs. And that's what we do. So in our team, the VNF Manager is in scope. The VNF Manager takes an application-oriented and narrowed view on the components what we have in a network. It's not taking into account the full picture. For that, we have invented in the telco domain a new component, which is called NFV Orchestrator, NFVO, Network Function Virtualization Orchestrator. That's the component which is in primary a singleton in a full network, and it takes control over multiple different VNF managers, maybe multiple different clouds, which are called virtual infrastructure managers in the telco networks, a lot of VNFs, maybe different EMSs, and a bunch of other things which are not visualized here. And the NFVOs are not necessarily always tied to OpenStack. We can have another type of clouds. Actually, they are around us, different type of clouds. So this needs to take a cloud agnostic view, right? And now that's another ingredient, it's another factor in our templates. How we are creating such declarations of a VNF that are really cloud agnostic. Plus, we also need to let the NFVO know that what are the lifecycle operations, what a certain specific VNF may provide, right? So one VNF is scalable, the other is not. It's just rigid. Or we may have some, an implemented upgrade procedure because it's needed, but for the other VNF we don't have, right? So you need to declare what are your lifecycle operations. You need to declare what are the parameters for the VNF, and you need to declare all those in a cloud agnostic way that you can support multiple different cloud types. And that's the VNFD. So this VNF descriptor, that is the new template format, new artifact that declares the general characteristics of the VNF. Now what we can do, right? So should we add some new format for that? Because that's not available directly in let's say, the OpenStack ecosystem. You don't have a format right away that captures all these different aspects together. And we said, no, we don't want to do, and actually we are looking into our community, in the telco community, and to figure out who's doing what are the trends. So first, a very important thing that in our main standardization body, which is called ETSI NFV, there has been a data model delivered that this is the thing what you need to capture in the VNFD. So basically it says that these are the parameters, the semantics of those parameters, types of those parameters, multiplicities, and so on. That's an accepted normative standard. Now we need to capture in some format. And basically ETSI selected Oasis Tosca as a standardization body to really create a template format for that. Tosca is doing that type of work for, I don't know, several years, starting the beginning of 2010 years. And they have a lot of expertise how to create such a template. And they have a modeling language, actually created a nice meta model and modeling language that is really geared to support this one. So now we are cooperating with our telco partners to finalize the Tosca definitions that are building on top of this data model which has been covered. Gabor is actually doing a lot of work in that standardization work. So that's the new layer in our template system. We are adding the VNF descriptor in Tosca, and that is going to capture the lifecycle operations. So you see a list of lifecycle operations that a certain specific VNF supports. You see what are the VNF level parameters, what you can give and that are influencing the operations related to that VNF. You need to have a VN agnostic VNF resource consumption and topology description. So an NFVO always understands that what is the resource consumption of a certain VNF, because if you have a lot, they can compete for the resources, and not all these local clouds are endless, especially as you go toward the edge. The resources are more and more constrained, so you cannot accept the virtually infinite capacity. So all these are combined in one VNF descriptor in the Tosca language, and Gabor is going to show a couple of examples how those are actually looking like. Good, so I'm now giving the mic to Gabor, and Gabor is going to speak a bit more about this whole Etsy terminology, names, new things invented in that area, and how those are linking to the OpenStack word. Thank you.
Thank you. So probably a few of you already came to your mind that what we are doing is similar to what Stacker is doing in OpenStack. Yes, it's similar in its goals, but we are doing it somewhat differently at the moment, at least, because we have to act very quickly and we have to solve very difficult problems in very short time. But I would like to show you really details of the templates. But first of all, I would like to introduce a few notions, because that's what the language that I will speak in. So in Etsy NFV, I just have to keep it. In Etsy NFV, on the highest level, we have the VNFs, the virtualized network functions, which communicate with each other via virtual links. And the virtual links are connected with the VNFs via so-called connection points. That's basically basic building blocks. And if we model them in a service template, in Tosca, basically the topology is a service template, then all these things like the VNF, the virtual link, and the connection points are all nodes. They are nodes of a graph. And they are connected together with relationships. That's basically the language. If we go one level deeper, where one VNF we would like to define, what is one node in a higher level, it is a topology in a lower level, then we have further ingredients of the topology. Like, for example, the VDUs, which are the virtualized deployment units, they roughly correspond to compute nodes, possibly with storage. And they can communicate inside the VNF via virtual links. And of course, there are the connection points inside. And certain connection points are exported on the boundary of the VNF as the external connection points. They appear the external connection points there in the higher level. Now, this is the cloud agnostic language, but the operator wants to see the VNFs in this presentation. But we have to deploy it in OpenStack. Fortunately, all these concepts map very well to OpenStack. So the VDUs become servers, Nova servers, the connection points become ports, and the virtual links become networks. The external connection points are somewhat special. In most of the cases, they are just a specific IP address on a given port. Now, going into more details, before showing concrete templates, I would like to summarize what is in there. So it's Tosca. I don't know how familiar you are with Tosca. It's a complicated thing at first sight, but it's easy to summarize because the service template consists of sections, which are always the same. They're boilerplate text in the template. For example, the whole thing is a topology template. Then below it there are node templates and policies and other things. Then what is really interesting is the actual node types that we use in the graph. We derived them from the Etsy specifications, and hopefully they will get into the NFV profile roughly the same way. In Tosca, there is an NFV profile existing. It has an outdated version at the moment, which is not compatible with the current specifications of Etsy, but there is a new wave ongoing. And on top of these standard constructs, we also introduced some Nokia-specific constructs, which help us putting all the things together. So Dánial mentioned that we use Ansible scripts. We have to somehow say in the template how we use them. We have Mistral workflows. We have to say somehow how we use them. And one such extension is, for example, the heat mapping, which actually makes the connection between the Etsy level language and then the heat language. So this is a fragment of a template. I try to annotate it so that it becomes easily understandable, but actually it's not so nice at first sight. I know, but let's see what it contains. So there are two main parts, the substitution mapping part and the node template part, at least in this example. The upper part, the substitution mapping, is actually the external interface of this VNF. So it says that everything what is written down there constitutes a single VNF node. By the way, this is the internal topology of this VNF. It consists of two servers. Each of them has a connection point, and there is a third connection point which is dangling and which realizes a so-called moving IP concept where one of the servers can grab the IP address. The details of this is not in the template. It's up to the software running on the servers how to do that. In the template, we just simply declare the necessary resources. So going back to the substitution mapping, it says certain properties about the VNF, how it appears on the upper level, so provider, name of the product, and so on. Then in the requirements section, it says that it has to be connected to a network, at least this connection point, which we call the external connection point of the first server. It has to be connected to an external virtual link. This helps the orchestrator to connect the VNFs together. And there are more for each connection point such requirement. And here, the middle part is listing the lifecycle management interfaces. It's important for the orchestrator as well as for the VNF manager itself, because it has to be able to instantiate the whole thing. And it says that the instantiate, the scale operations are supported. The other part, the node templates part, simply lists all the nodes in the graph and their relationships. They are not really detailed in this example. But just to say what it is, so for example, the server 1, the upper one is a VDU, and when the VNF is deployed to the cloud, it will become a server, as I mentioned. Now, this part here says doesn't tell too much about the lifecycle management of this, because the VNF manager from this information already knows that how it will instantiate the VNF. So there is also a heat template in the package, which will be deployed to the cloud. The stack will be created. This is a built-in implementation of these operations in the VNF manager. But in most cases, this is almost good, but just not enough. And in those cases, these operations can be extended a little bit. And this example shows how. For example, the instantiate operation contains the heat stack creation, which is implicit. It's not written here. But before the heat creation, we can somehow modify the zone, availability zone assignments. For that, we can use a JavaScript code, which modifies the stack parameters. And after the stack is created, we can use an Ansible playbook to do a configuration on the server. So, for example, to make a bunch of servers one cluster, configure them so that they can see each other and form the necessary functionality. There are also other possibilities. For example, the heal operation. It's not implemented in the VNF manager, but it's possible to provide a workflow in form of a Mistral workbook. And similarly, any other operation can be implemented by the VNF. Thank you. By the VNF provider. And on this level, we can see the heat template of the VNF, and I think it's familiar to everybody that it contains a Nova server. What is interesting here is that the NFV model is appearing in this picture in a way that necessary data is injected into the stack. This happens via an input parameter, which is called CBAM. CBAM is the Cloud Band Application Manager. And the application manager actually computes this structure in advance based on many information which it received at instantiation time or in a so-called granting phase, which is not detailed. Dánial didn't talk about that. But anyway, all the necessary information which is needed to really put the VNF into its environment are provided in this structure. And such information is, for example, what should be the actual image of the server. So the VNF provider can ship the image with the VNF package, but who knows in advance what will be the name of the image in the cloud. It will depend on the person or the automation which deploys the image to the cloud. And similarly, we can set the compute requirements in the template in the VNFD, but we don't know what will be the flavor name for corresponding to that. And this information is propagated to the heat stack, computed automatically and propagated down. And for example, it turns out that the flavor ID will be the tiny one on this OpenStack installation. I hope that I was able to show at least something about the details of the template. Much more can be shown, but time is running out. I let Dánial to wrap up.
Yeah, just a very short wrap up. So basically what we learned, we went through a process of designing a template system, and we have been giving you a couple of snippets out of that. That's, of course, just selective and very narrow examples. The time would not permit to go into a deeper level. But nevertheless, of course, we have been capturing all this information in many details. We are providing a complete template developer guide, a full VNFD specification that are using these formats. So these are available to our partners to develop the integrations with our VNF manager. Of course, these integrations can happen with Nokia VNFs as well as third-party VNFs, so this is fully open and, as said, relying on the generic community templates explained in this presentation. So, what we have been achieving, what is the key result? We think that such a template system really enables the VNFs to be part of the cloud game. They are truly becoming part of the cloud and benefiting of the automation. These are not just occasionally deployed there just to say, okay, it's in the cloud. These are really taking over whole spirit of automation, what we see in the clouds, right? So they are brought to life, they are managed in a very efficient way, right? And being open, it means that we can work very closely with a lot of partners. Not just Nokia, but all our partners, being competitors, being actually just OEM partners, and deliver solutions to our customers. So I think we are getting one step closer to actually realizing the NFV ambitions. Thank you. So we have, I guess, 5 minutes for questions. So if you have any questions, just let me know. I'll try to answer those. Everything was clear, so there's no need for more questions. Is there any doubt, any unclear area? Okay. If not, if there are no questions, I think... okay, you have one question, please.
Did you face any problems or say, challenges with scaling out?
No, I don't think that scaling is the area where we are feeling challenges. Where we see the most complex things happening are around upgrade, as I mentioned. the in-service upgrade of VNFs in a way that you are changing the topology of the VNF itself, so are adding new external network connections, you are changing the networks internally, externally. That's probably the most complicated area where we are still working and delivering additional features. Any more questions? Yes, please.
For in-service upgrade, are you considering the existing VNF's capability of doing the upgrade, or you're providing completely new?
No, so yeah, that's a very interesting question. So we have observed that the upgrades are very, very much VNF specific. So we have not been providing so far one generalized built-in workflow for the upgrades. Instead, what we are providing a lot of Lego blocks, what you can use as a part of the upgrade, but it's up to the VNF provider to create out of these Lego blocks a full workflow, and it's going to be VNF specific. It requires a lot of harmonization across the VNFs to be having one synchronized or one generalized upgrade procedure.
And does it involve the scale out as well? I mean, like increasing the VNFs and then upgrading the existing ones?
Yes, of course, we can upgrade a scaled out VNF, so it can be upgraded in any of the situation it belongs at a certain point in time. What's even more difficult, and that's not yet handled, that in our system, so not just in the template system, also in our implementation, that you are scaling in and out while doing the upgrade. So having two parallel operations, that's very difficult to handle the concurrency, parallelism. At this level, it's not yet handled. Okay. More questions? No more questions. Good, thank you very much. And we go to the next presentation.